Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 9 of the February daily LeetCode challenge. First of all, congratulations. We are about to complete one third of this month. So if you haven't consistent till this point, a big congratulations. Because for the first 5 days we had questions on arrays which were easy level. From after that, after day number 5, we are having questions on hash map and they are all medium level. So I guess this is the fourth medium level question that we're having in this month in a row, right? Now coming to this topic, it is 2364. Remember, it's like a very, very good question. It's like you can think of this question, mostly this question are asked in online assessment rounds because there is a trick involved. If you don't know the trick, it will be very difficult for you to solve this kind of questions in a most optimal way, right? Let us see what it is. So first of all, see that we are given a integer array, and let me quickly show you the constraints first. Okay, and if you see acceptance rate, it's very, very low. Okay, like by the time I started solving, it was around 47%. Now it is 51%. Still it is very low. Even some of the hard programs are having much better acceptance rate than this. Okay, so this tells us how difficult it could be. But remember, the question is simple, but only thing which is difficult is how to solve optimally, right? Now if you see the length of the input, it is going to be in the range of 10 power 5, and each value is going to be in the range of 10 power 9. Okay. Yep. I will show both Python and Java solutions, and yeah, we'll discuss the differences that are coming in both of them. Okay. Now, what we have to do. See, it's very simple. We are given a zero index integer array nums. A pair of indices I comma j is a bad pair. Okay. If I is less than j. Okay. See, this part is very, very important because if you ignore this part, then things are going to be very different for you. So please pay attention. I has to be less than j. Okay. In this, then there's giving a calculation j minus I. Okay. So remember, since I is less than j, so j minus I is going to be a positive number. J minus I is not equal to nums of j minus nums of I. Okay. Now that is for every pair you will have to do this particular calculation, and if these two values are not equal, then you can say that I comma j, the pair that is getting formed with I and j, is a bad pair. Okay, and finally we'll have to remember you have written the total number of bad pairs in nums. Okay, I hope the question is clear to you. It's a very simple question. There's nothing much. You'll have to like go for every pair possible. Okay, such that I has to be less than j. And see, the idea here is, if you don't give this condition, can you quickly tell us what will happen? What will happen is, whatever is the answer, that will get doubled by c for every I and j. Okay, one answer will be where I is less than j, other answer will be where j is, okay, the other way around. Okay, the other way around, right? So the idea here is we want only in a single way it's to be taken. For that's the reason why we are introducing this condition. Okay, as simple as that. So if you see this case, so can you quickly tell me what are the total number of pairs that are possible? In this case, it is going to be 3 plus 2 plus 1. Okay, which is equal to 6. So there are 6 pairs possible. Out of them, they are saying 5 of them are odd pairs. Okay, so the pair 0, 1 is a bad pair. Since okay, they're giving the reasons for that also. You can go through all of them. Why the reason is it's like that they're mentioning, you can go through them. Okay, similar example number 2 also, you can go through it. Okay, see, there is nothing much for me to explain. That's why I'm skipping this part, because they've already given a lot of calculations. Let me quickly jump to the logic building part of this. Okay, we'll do some rearrangements like we do in maths. Okay, so if you are good in maths, you will find these things slightly, I will say, usual, because these things are very common in maths. Okay, so see, this is just something that is given to us. Okay, j minus I, okay, is not equal to nums of j minus nums of I. Okay, where I is less than j. Okay, now let me rearrange the terms. What I'm doing, very simple. It's very simple. See, this particular term. Okay, this particular term I am now taking it from RHS to the LHS. Okay, as simple as that. Okay, similarly, this particular term I am taking it from LHS to RHS. So what will happen now? See, it will become nums of I minus I is not equal to nums of j minus j. So what we have done is, in both the right hand side as well as the left hand side, we have only expression with the single, okay, variable. That is, see, this whole variable, this whole term is now with a single, this whole side, okay, this whole RH is now with a single variable, this whole LH is now with a single variable. So what advantage does it bring to us? See, it's very, very simple. Always remember this part is still there. I has to less than this till now. Okay, still here also. Now, see, initially when you saw this question, can you quickly tell me what is the time complexity that you have thought you can solve this in? Obviously, it has to be O of n square, because you have want every pair to be checked for this particular condition. Okay. Now, but after coming to this particular step, can you quickly tell me now what could be the optimal time complexity that with which you can solve this question? Now it is going to O of n. Why it is like that? I will tell you now. See, this whole time, if you see, it's going to be dependent only on I. Okay, so if I am at a particular index I will know both of them. Okay, I know the index I also, I know the value for that index also. So this particular term can be calculated with ease. Okay, with a single O of n solution, okay, we can calculate this term. But how to do the comparisons? See, for comparisons we have a very good thing to do. See, now any index j, okay, can form pair with index I if I is less than j. Okay, I will again repeat, any index j can form pair with index I if I is less than j. Okay, so can you quickly tell me how many total pairs are possible for index j. I'm talking total pairs. I'm not talking about good or bad. I'm just talking about total pairs. So let us call that term as x. Okay. So total number of pairs that index j can form is equal to j. So what it means, see. Let us go to example number one. In this particular case, see, this particular 3, as it is at index 2. So how many pairs it can form? It can form 2 pairs. So let us see how. See, 3 can form a pair with 1. Okay. Similarly, 3 can form a pair with 4. So total pairs that it can form is 2 by c. Obviously, it will only form pairs with the indexes which are smaller than it. That's why if you see, there are only 2 indexes which are lower than this particular index. Okay, so that's why it can form only 2 pairs. Okay, I hope this point is clear to you now. If the index is j, so it can form j pairs in total. Okay, it's not about see, it's not about good or bad. It's just about total pairs that it can form. Okay, as simple as that. Okay, fine. What is the other part? See, now we have calculated x. X will tell us total number of pairs that the index j can form. Okay, it is going to be j itself. Now, can you quickly tell us what will the total number of good pairs that j can form? Okay, it's very simple. Total number of good pairs will depend on like how many indexes which are less than j are getting the same value like this. Okay, how many indexes which are less than j are getting the value which is same like this. Okay, which is same as that of the current index j. Okay, as simple as that. For that, we will use a hash map. Okay, to store that, we'll use a hash map. Okay, as simple as that. So I will come to this part after I explain my solution. But for now, let us see how what happens. Okay, see. I am, creating a hash map. Okay, as what is hash map? Basically, hash map means there will be key and a value pair. Okay, as simple as that. So, what is the key going to be? Key is going to be the value of this particular expression. Okay, key is going to be the value of this particular expression. The value is going to be the frequency of that means how many times this particular expression has occurred in the past. Okay, let us see how it works. So, this is the going to total number of bed pairs now. I'm going from each index from 0 to n minus 1. For each index, basically, I'm calculating this value. What is this value? This value is coming from this. Okay. For each index, I'm calculating this value. Okay. Nums of I minus I. Okay. This I'm calling as a value. Okay. This is something that we want to track. Okay. That is whenever I'm at index j, I want to know, okay, this particular value for the current index j occurred how many times in the past. For that, I'm going to use this particular hash map. Okay. So what I'm going to see, I'm going to do this part. Good pairs of val plus equal to 1. Okay. So remember, since I'm using a default dictionary, so the default value will be 0. The default value will be incremented by 1. Okay. Now, this will tell us that, see, we have to understand the sequence very carefully because, see, it's not going to be easy if you try to understand the first two. Okay. So please pay attention now. What is happening? See, I'm calculating this value. Okay. Now, as I mentioned, see this part now. I have the total number of pairs that index j can form is j. Okay. Now, the total number of good pairs that j can form is equal to that is basically something like for the indexes which occurred prior to that, how many of them were resulting in this expression equal to the current expression. Okay. That is, this particular val occurred in how many other expressions for indexes which are less than current index j. Okay. So that will be something that we can get from this. Okay. This is the expression. Okay. Now this is the expression. Okay, now we need to know how many times this expression occurred in the past. That is what, so this, that's why we are passing this expression as a key in this particular hash map. Okay, so that's what we are doing it here. See, I minus, okay, so this is, okay, this is the total number of pairs, this is the total number of good pairs. Okay, this is the total number of good pairs. So what is the total number of bad pairs? It is going to be j minus this particular value. Okay, let us say this particular value is x. So x minus y is going to be a total number of bad pairs that j can form. Total number of bad pairs that j can form is equal to x minus y. That's what we are going to do now. See, this is the value. Okay, so how many total bad pairs are there? See, I is the total number of pairs that j can form, and similarly, total number of good pairs that j can form is given by this value. Okay, that is how many indexes in the past, that is how many indexes which are less than current index j, when evaluated with this particular expression, okay, resulted in the same value as the current index. Okay, resulted in the same value that of the current index. Okay, remember, this is the hash map. It will give us the frequency. But it's a default dictionary. That means the default value will be 0. If the value occurred in the past, then it will be non-zero answer. Okay, as simple as that. So that I minus this particular value. Okay, I is the total number of pairs, and this is the total number of good pairs. So total number of pairs minus total number of good pairs will give us total number of bad pairs. That is what is being added to total number of bad pairs. Okay, after this thing is evaluated, then only after then, okay, only after that, this particular value will increment. Okay, that is total number of in good pairs will go to this particular value and increment its frequency by 1. Okay, remember, till this stage we did not do that. Only after this particular calculation we are doing that. Okay, as simple as that, right? And finally we're getting the total number of bad pairs. So I will again show you what is being done. See, first of all, we are calculating total number of pairs that j can form. Okay, then we are calculating what are the total number of good pairs that j can form. To calculate this part, we are taking help of a dictionary. Okay, we are taking help of a hash map. Okay, we are passing this particular value as the key. What is this value and where it is coming from? It is coming from this part. So we want to know till now, among all the indexes which are less than j, among them how many of them resulted in this particular expression. Okay, that value will be given by this particular term. Okay, in good pairs we are passing this particular value as a key, so the value of this thing will give us how many times this expression occurred in the past. Okay, that will basically, so okay, that will tell us the number of indexes which result into this particular expression. Okay, so current index j can form a pair with them. Okay, so that's why this answer is whatever it is coming is going to be the total number of good pairs. Okay, as simple as that. So total number of bad pairs equal to total pairs possible minus total good pairs possible for index j. Okay, as simple as that. So as you can see, it is going to be x minus 5. Okay, as simple as that. That's why we are doing it here. After this calculation done, then since we have evaluated this particular value, and for the current index we will now increment the frequency. Okay, as simple as that, right? Finally we're returning the total number of bed pairs. So let me quickly run this and show it to you. So as you can see, this is clearing all the test cases. Let me now quickly show you the Java solution for the same. Okay, remember the only difference here is only the difference coming is C. In this case, you will have to return a long answer. Okay, long integer answer. But in Python there is no such restriction. Okay, you can simply return integer answer. Okay, as you can see here. But in Java we have to return a long answer. Okay, same thing here. We are calculating the length of the input. Then we are creating a map. Okay, both key and value are going to be integers in this case, and I am passing a value n because in the worst case, remember, we will have to store n key value pairs. Okay, as simple as that. When all of the indexes are giving a different evaluation for this particular expression. Okay, in that case, that will be the worst case where we'll need n key value pairs. Okay, for that reason I'm already passing this value. The advantage here is that at the start of the program itself, enough memory will be allocated to this particular hash map where it can store n particular, okay, n max key value pairs. Okay, as simple as that. So that during the runtime it won't have to ask for any additional memory. Okay, because that is a very time consuming operation, right? Now I've declared this as a long value or long data type. Now I'm going through each of the indexes. I'm calculating the expression. Okay, this is the expression I'm talking about. Okay, as simple as that. Once I calculate this expression, next I have to calculate total number of bed pairs. Okay, for that what I have to do, I have to subtract total number of pairs possible for current index j, subtracted with total number of good pairs that current index j can form. Total number of pairs possible minus total number of good pairs will give us total number of bad pairs. That I am adding it to this particular value, and at last I am returning this value. Okay, now in between, after this calculation, what I have to do, I have to, since this value is already calculated and I have not incremented for the current index, that's why I'm doing this part. Okay, this looks very clumsy, but in Python you can see this is very simple. Okay, this is just like that. Okay, so for this particular key, I'm just incrementing the existing value. Okay, that's what we are doing it here. Okay, if you see this, I'm putting a new value. This is the key, and this is the value. Okay, what is the value? If there is an existing value, take it and do increment plus 1. If there is no existing value, take the default value 0 and then increment it by 1. Okay, as simple as that. So that is what we are doing it here. Okay, since it is a default dictionary in Python, so don't have to write the additional steps because we have passed int here. If you see, so by default every value for any new key will be 0 only. Okay, that's why we can simply do plus value here. Okay, as simple as that. But for Java, we'll have to like pass the default value as 0. Okay, as simple as that. So yeah, friend, that was all for this video. It was a O of N solution in terms of both time and space complexity. I know this was a tricky question, and the acceptance rate basically clearly explains that part. Okay, 51.6 is definitely very low one. I have seen some hard problems which have higher acceptance rates than this particular question, though it is a medium level question. So definitely it was something that is definitely hard. Okay, if you don't understand this logic, definitely it will be hard, and I can expect this kind of questions in a online assessment rather than a face to face interview, because here there is some trick involved. Okay, there is only the trick part. Other than the trick part, there is nothing much to think of. Okay, there is nothing much for you to show to an interviewer if this question comes. Okay, by default, if this comes in a face-to-face interview, you will be expected to solve using O of N square, and then by some hints you should be able to solve in a O of N solution. But again, as I mentioned, what according to my own experience, what I can think of is that this will come in online assessment only. Okay, they will not ask this kind of questions in a face-to-face interview because there is very less for us to discuss in a face-to-face interview when such a question comes. Okay, the code is very small. At the same time, the logic is also very small. There is not much up to alternative approaches for this. Okay, so that's why I felt this is not a face-to-face interview question. This is an online assessment question because there is a trick involved. If you know the trick, you can solve it with this in a very short time. Otherwise, it will take a long time for you. And what I can anticipate is that since they have done this thing, see, if you see, it is going to be 10 power 5. Okay, so what I can think of that if you solve using O of N square, you will get time limit exceeded error. Okay, that is what I am anticipating, but again you will have to check. I did not try that. Okay, I directly tried this particular approach, but you will have to check whether O of N square they are accepting or not. According to me, they will not be accepting that because O of N square there is huge difference. So since O of N is possible, they will not be accepting O of N square solution. Okay, so yeah, fun, that was all for this video. Only thing in Python is you have to memorize it's a long data type. You have to pass this value n, and yeah, that is all. Okay. Then you have to create this map with integer and integer. Yep, that was all that I can tell you. In Python, there is new concept for you to learn is default dictionary. Just Google it out. There is this is very good stuff for you. This you don't have to import any lessons library, but yeah, normally the collections library will be auto imported. But if it's not imported by default, you have to import it in the collections library. Okay, this is present in the collections library. You have to import it from there. Okay, as simple as that. So yeah, friend, that was all for this particular video. If you like my parts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.